All right, so with solving equations, basically here's what you're going to do. If you're looking at an equation that doesn't make sense, if you're going through this, and this is kind of me just thinking out loud for this part, is that if you cannot solve an equation the way it's written, then you have to rewrite it to solve, which means it may be an exponential equation. You may have to rewrite it in log form. It might be a log equation. You may have to rewrite it in exponential form. It may be that it's got the word log in there 2 or 3 or 4 different times, and you might have to condense it down so that you've got just one log expression. So it's basically one of those things. And there will be some equations, though, that you're going to look at and you go, oh, I can just, it may be something you can just punch straight in the calculator because the way it's set up. And then you kind of go from there. So. Okay, so first one we'll do, and this is kind of more like what we did on the very first day, I guess, as we were going through some of this. Now, in some of these, and we'll show you actually 2 different ways that you can go through and solve this one. Because some of these, they will tell you to rewrite it with a common base. So if you've got 2 to the x equals 16, if it says rewrite and use a common base, that will show you the way that they want you to solve it, and then we'll show you another way that you can do it without doing it this way. That's a little bit. Some people say it's the easy way, and we'll show you both just to be on the safe side. Okay, so if you got 2 to the x equals 16, 16, if you rewrite it with a common base, is basically we're going to rewrite this so it's base 2. Well, 16 would be 2 to the 4th. So if you've got 2 to the x power equals 2 to the 4th power, as long as the bases are the same, you can just get rid of the bases and just solve what equation you've got left over. So then you've got x equals 4. Okay, and we're going to do a little dash line here on this one because we're going to do a what if. Because here's another way you could solve this one. And it doesn't really matter because I think as long as you go either way, it's fine. But we're going to kind of show you both just to show you. Sometimes you're going to do these and you almost, I wouldn't say you have to do it this way. But sometimes it's easier to do it this way. Sometimes it's easier to do it this way. This is one where you can kind of go either direction to be fine. But if this is, let's just say you didn't know what 2 to the x was equal to 16. If you didn't recognize right off the bat, if you looked at this and you were like, let's say you didn't recognize that 16 was 2 to the 4th. So let's say this was gone. If you're like, well, I'm not sure. If you do like we were doing 2 days ago, or if you had 2 to the x equals 16, if it's in exponential, let's rewrite it in log form. Okay, so to put it in log form, of course, we have to put the word log in there. The base will stay the same, and then you just switch these 2 numbers. And if you take it from exponential and rewrite it in log form, well, now you've got it this way. Well, you can just punch that straight in your calculator. You don't have to do anything. So here's where you get some calculator practice. So we've got log 16 base 2. So we're going to do the log of 16. And again, if you're going to do it on the Texas Instruments, make sure you close off that parentheses and then divide that by log of 2, and you still get the same answer of 4. Okay. I know somebody's thinking, does it matter which way we go with this one? Technically, no, because you'll get the same answer. So whether you think about it as being 2 to the 4th power or rewriting it from exponential to log, it doesn't really matter because you can kind of go back and forth on these. There will be some questions where you have to do it this way, just based on the way some of the numbers are. Okay. Everybody okay with that one? Everybody okay that you've basically got two options to go for this one? All right, so example two. Similar to it, but something just a little bit different. So we've got 3 to the x plus 5 equals 9. Oh, and for this one back up here, if you need to, again, if we were going to do this by calculator, again, this would have been log of 16 divided by log of 2. Again, just make sure on that one that you close off that parentheses. The 2, if you do that, it's okay if you do. If you don't, it's okay too. But on the 16, on the top number, you have to make sure you close that parentheses off. Okay, so for this one, again, if we're going to go with the common base for this part, 9, you could rewrite it as 3 squared. And again, as long as you've got the same base, you can get rid of the bases and just solve what equation you have left over from there. Okay, and then from that point, not a whole lot to do there. Just subtract 5 from both sides, so then you get x equals -3. Okay, and at the same time, though, we're going to show you this same problem, but we're going to rewrite it. So over here, we're going to do a separate problem. We're going to rewrite it in log form just to see what it would look like. So if we rewrite it in log form, your base is 3, so that will stay there. And again, we're going to switch these two numbers. So the 9 will go there, and the x plus 5 would go there. Okay, which means we've got to do log of 9 base 3, or log base 3 of 9 on this left-hand side to find our number, which means, again, we get to use our calculator, so we're going to do the log of 9 divided by the log of 3. Gives us a 2. And at that point, now we've got the exact same thing we had here. So again, it's the exact same answer, so we know the answer is going to be -3. Okay, and again, it's going to ask you some of these. It might make you use the common log, so it may give it where you've got like a base here, and you may have to plug in some numbers. So just kind of be able to go back and forth on these. Now, test-wise, if it's just find the answer without showing work, either way is fine because you get the same answer going either direction there. So but again, just kind of be able to do both of these because this is rewriting it with a common base, and this is using a calculator. Okay, so one more of those for sure, and then it's got a little twist on it. So let's go 4 to the 3x power equals 1 over 64. What? Okay, now if the fraction's throwing you off, let's do this just to make things feel a little better. What if that wasn't 1 over 64 and it was just 64? And for this one, let's just kind of do this on the side over here. Everybody okay that if you do 64, that would be 4 to the third power? So if it was 4 to the 3x equals 64, it would be 4 to the 3x equals 4 to the third power. But it's not. It's 1 over 64. So that goes back to that very first day we were doing exponents, that the only difference between 64 and 1 over 64 is that instead of this being a positive exponent, it's a negative exponent. Okay, and again, if we've got it there, bases are the same. So we can get rid of the 4's. We'll just do 3x equals -3. Solving that one, pretty easy. We get x equals -1. Okay, now beside that one, let's take this thing and rewrite it so you can see what it would be to look like to rewrite. Because again, sometimes there'll be numbers that you look at and the numbers don't just jump out at you sometimes. So you may get one like this and you're like, I don't know. I don't know with a 1/64. I don't know how to rewrite that with a base 4. So if you looked at that and you were like, okay, I don't know what's going on here, we're just going to take this thing and again, just take this part in and just rewrite it. So if we rewrite it in log form, again, 4 is the base, it'll stay here. And then just switch these two numbers. So that's 1/64 equals 3x. Okay, and it becomes a calculator question. And this is just being able to put the number in the calculator and get what we need there. So if we're doing the log of the top number, that's log of 1 divided by 64. Again, just make sure that whatever that top number is, 1/64, make sure you close off the parentheses and then divide it by log of 4. We still get that same number of -3. Okay, and you still get x equals -1. So if the numbers don't jump out at you, if you're looking at this one and you're like, yeah, I don't know how to rewrite these with the same base. If you can't do the same base here, you can always use your log expression to find the number because it'll set up and go easy from there. Okay, now for the next one. So this would be almost like a second set of problems here. You've got 2 to the x equals 3. Okay, is there any way you can take 3 and rewrite it with base 2? No. If you can, you're a super genius and you don't need to be in this class. So yeah, I don't know what that number would be. So what we're going to do in this case is we're not going to be able to do this. You're going to have to rewrite it in log form. So for this one, you don't really have an option. You're going to have to rewrite it in log form. You need some water, Julie?
No, I have some. It's just not out.
Okay. Okay, if we rewrite it in log form, the base will stay the same. Again, we're going to switch these two numbers to get our value. Okay, and again, from there, it's just all calculated. So it's log of 3. And again, just make sure you close off that parentheses divided by log of 2. And again, they should tell you to round this off to either 2 or 3 decimal places. So if we go 3 decimal places, it'd be 1.585. Now, I do know that some of the questions in the homework, and I can't remember if they were this way or not. Some of these, if they tell you to use your calculator to rewrite it, they may actually make you rewrite it as log base 3 over log base 2 and then give you the answer. So they may make you go from here to rewrite it like this and give the answer. Now, test-wise, I'm not going to ask you to do that. Test-wise, it's going to be just, here's this problem and just solve it. So I wouldn't make you actually have to show this part of it. You just need to know that that's, how you got to get there to get this part. But I think some of the homework questions, it may make you do that. Oh, sorry. Thank you. Yeah, 5 does come after 4. Thank you. All right, so here's another one. And again, this is when you have to use the log expression because there's no power of 3 that you cannot take 17 and break it down as 3 to the power. Now, again, if you know exactly what it is, that's great, but I don't think most people do. We can kind of ballpark it because you know that 3 squared is 9. You know that 3 to the third is 27. So that's 17. So it's going to be about 3 to the 2.5-ish. But again, we don't really need to know that because we can rewrite it in log form. Okay, so if we put it in log form, again, the base will stay the same, and then we'll switch these two numbers. Okay, so if we do log 17, divide that by log 3. There we go. So it's about 2.5789, which again is kind of what we're saying. We know that 3 squared is 9 and 3 to the third is 27. So if we rewrite this thing in log form, we know that that number, that this 17 would be rewritten as 3 to the 2.5789 power. Now, here's one thing you have to do. On a lot of these problems, when you get this, they will tell you to not round the answer until the very last step. So you've got to basically write down as many decimals as you can stand. So don't just put 2.57 because it's probably not going to give you the correct answer. It's one of those where you probably want to leave that number in your calculator, especially if this was like dividing by 2. Now, if you subtract 2, it's not going to be that bad, but we're just going to take that answer and we're going to subtract 2. So we can see that that answer would be 0.5789, and that's what we actually round off at the very end. So 0.579. Okay. And again, with addition and subtraction, you're probably not going to miss anything. But if this number winds up being like multiplication or division, where you've got to do some multiplying and dividing these numbers, that's one where you almost have to wait to the very end before you do anything with it. So if it gives you this big, long run-on number, just work with that number till the very end and then round that answer off at the very, very, very end of it. Okay, so all those were where we started off with exponential functions. And again, some of these we could rewrite it with the same base. Some of these we couldn't. We're going to go the opposite direction on this one. We're going to start off with some expressions in log form. Everybody good there before we move on? Okay, so for these, we're going to rewrite it in log form. Or sorry, start with it written in log form. Okay, we'll do number 6 because 6 comes after 5. Make sure I got it correct now. Okay, so let's go log of 2x equals 1. Okay, and very first thing is that, again, if you don't have a base on this part, you got to know that the base is 10. So as soon as you've got it written, if there's not a base, just go back and put a 10 for the base of it there. So this is what we're working with. And again, this is because of this x, you cannot punch this thing in the calculator like it is. So what we're going to have to do then is we're going to have to take this expression and we've got to rewrite it back into exponential form. And again, to me, this is the easier one because if you're rewriting exponential, you take out the word log, the base will stay here, and then you switch these two numbers. So it's 10 to the first equals 2x. Well, 10 to the first is just 10. And if 10 equals 2x, that means x has got to equal 5. All right, let's give you one that's actually got a base other than 10. See what happens here. All right, so let's go log base 3 of 2x plus 1 equals 2. Okay, so again, you cannot solve that one because of the x that's in the log with expression on that side. So we've got to rearrange it and rewrite it. So that's going to make it 3 squared equals 2x plus 1. Again, we just take out the word log, the base will stay the same, and then just switch those two things that's there. And again, when you do that one, now you've got 3 squared is 9. So it's 2x plus 1 equals 9. So now we just get to solve that equation, which is not bad at all. Subtract your 1. So we got 8 equals 2x. Divide by 2. And we got x equals 4. Okay, so whether it's log, you rewrite it from log form to exponential. They give it to you in exponential, you rewrite it and put it in log form. And again, whichever way you go, it should be an easy way. After you rewrite it, there should be something that should just jump out at you and go, oh, okay, there we go. We've got what we're looking for when it comes off this one. Okay, now one thing we've talked about a little bit, but we haven't actually solved any problems with this one just yet, is natural log. And again, if you're doing the homework, you can put in capital L, you can put in capital N. I think a lot of times you will see that. Again, if you're looking through some of the homework problems and they talk about LN, they'll write it like this. Don't put IN because sometimes people put IN. Remember, that's an LN. And again, sometimes when you see it, you'll see it written in script. So it looks like that. But they're all three the same thing as you go through this one. So I think this is more on your calculator. This is more what you'll see on Math Excel. Test wise, if we're working something out, I'll take any one of those three. I don't really care. I kind of like that one just because it looks neat. You know, with the script, with the cursive, it just looks kind of nice. Okay, so for this one, again, what we said yesterday is that natural log uses base E to solve the problems and do what you've got to do. Again, when we said E, that was that number of 2.718, and it ran on forever, but we said basically it's 2.718. We're going to do it for short for this one. And to count, to kind of balance these things out to do what we need to do for this part is this. If you can get LN and E so that they're touching that together. Okay, and again, when we're saying together in this case, they have to actually be touching. They've got to be right beside each other. You can't have a plus or a minus or some other number in between. They've got to be right beside each other in some way or another. They will cancel each other out. You know, just like if you have the square root of x squared together. Not you have to write this down, but if you can put the square root of x squared together, how they cancel each other out and just gives you x. It's the same thing with ln and e, is that if you can get the ln and e together, they will cancel each other out and just give you whatever number that you have there. Okay. And these are some questions that, again, you can do this without a calculator. This is one of those you can just look at it and know what the answer is, and there's no work to show for something like this. And yes, there will be a problem like this on the test. It's just that easy that you don't even have to do anything. That you've got the ln of e to the fifth. And you can even punch this in your calculator if you want to. So if you've got the ln of e to the fifth power, you close off that parentheses, the answer is just 5. So where you've got ln e to the fifth, basically what's going to happen is it's like a magnet. If you put these two things together, they just kind of knock each other out, and your answer is just 5. And that's true every time, regardless of what they throw at you. It could be the ln of e to the 3x plus 4. Again, as long as the ln and e are touching each other, they're going to knock each other out and give you 3x plus 4. Okay, now that's if they give you ln first. Now, if they put e first, still works the same way. The only difference is that if it's e, it's always in the exponent. So just like on your calculator, if you punch in e, it's automatically not you can see it there. It automatically makes it an exponent form. So when we do e after that, everything else is going to be in the exponent. But again, the e and the ln are still touching; they're still together. So that's still going to knock each other out. The answer is just going to be 7. Okay. And you're thinking, well, this is going to be really easy. Well, yes, but we're going to make you now. Some of these you're going to have to go one more step because they're not always going to give you e and ln together. So that's kind of this is kind of the preview before we actually start solving. So if you can get the ln and e together, again, they'll knock each other out and just give you whatever's left over with what's there. So if you're going to solve, problems with ln, you're going to rewrite both sides with base e. And then from there, you should be able just to plug it in and simplify it. And if you can't simplify it, you don't know what the number is, just use your calculator, and then you can go from there. Okay, so here we go. So here's one where you've got the ln of 4x equals 3. Okay, and again, so it's basically like the problem we had back up here, that if we can get the e and the ln together, they will cancel each other out. So all you have to do in this case is that we need the e here to cancel this part out. So if we put the e here as the base for this left-hand side, you have to also have to put the e as the base on the right-hand side. Okay, so it's a good news, bad news. The good news is where you got the e and the ln, those two things are going to cancel each other out, and that's just going to leave you with 4x. Now, the bad news is that most of us aren't used to using e as the base, so that's 2.71828282818 to the third power, and I don't know what that is, so that's where you're going to have to use your calculator. And I already had it there. Whoops. So you're going to have to take e to the third and tell me what that number is. Okay, so that's 20.08553692, blah, 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 all that other stuff that's here. So that's about 20 point. Again, you can't just say that it's 20.0 or 20.1. You need to write out 4 or 5 or 6 numbers on this thing. So now the best case scenario would be to leave all this stuff here. Now, if it was x, we could just round it off and go from there. But again, it's 4x. So after we get this number, we just need to divide it by 4. So just leave that long number in your calculator, divide it by 4. Now you've got the final answer. That's the part you can round off to 3 decimal places. So we can make that 5.021. 3 doesn't impact it. So that would be our answer we're looking for there. Okay, let me give you another one of those. Just make sure we got it. All right, but everybody good with what we did? Anybody not okay there? Let's go with the ln of 9x minus 6 equals 4. Okay, and again, if the ln wasn't there, that'd be an easy equation to solve. So to get rid of the ln, again, we've got to take e on both sides. So it's the e raised to the ln of 9x minus 6 equals e to the fourth. And again, the good news is the e and the ln cancel each other out. That's just going to leave you with 9x minus 6. The bad news is we don't know what e to the fourth is, so we've got to punch that number in on the calculator. Okay, so if we go e to the fourth, that is 54.598. Okay, so we're going to put 54 point something. Now, again, here's where that if you know how to solve equations, you don't really have to show your work, because if you're going to do this one, if we're going to solve this equation, what's our next two steps? Yeah, we're going to add 6 and then divide by 9, right? So you don't really have to write out the steps on this one. Just have your number there. So then we're going to take this answer, we're going to add 6, hit enter, and then we're going to divide it by 9. And that's the answer we've got to round off. So it's 6.733. Okay, so as you're working through these, you don't really have to write down every single step. The main thing, again, is really just making sure that if you get the e and the ln gone and you got this side, just make sure that once you're here, you know what to do with what's over here. And there shouldn't be like 10,000 steps on these. It should be, pretty much just pretty straightforward 1 or 2 steps. Try one of those. No. Okay, let me give you one more that's got a little bit of a twist to it. All right, so here's the difference on this one. We don't have one ln expression, we got 2 ln expressions. And you may be thinking, oh, well, I'll just go ahead and put an e here, I'll put an e here, and I'll put an e here. Now, if you do that one, if you put an e on this side to cancel this off, then basically this whole thing would be e to the power. So that's not really going to work, because now you got this e and ln together here, but that ln has got all this other stuff around it. So that's really not going to work for this one. So what we're going to have to do is, if they give you multiple ln's, what you're going to have to do is you're going to have to take these two expressions, and you're going to have to do like we did yesterday. You're going to have to condense those two things. So that's where we got to go back and use those log properties that we were looking at yesterday, I think. Yeah, I believe that was yesterday. I've been 2 days ago. Anyway, all right, so the plus in the middle means you've got to take those two things and you've got to multiply 2x times 3, which, again, not bad at all. That's just the ln of 6x. Okay, and now that we've got it down to one single log expression, or in this case an ln expression, then you can do e to both sides to get what we're looking for. Okay, so the e and ln will cancel for this part of it. That'll give us, and bring that, putting it back over here, that'd be 6x. E squared. That is 7.389, blah, blah, blah. But again, it's 6x equals that number. So we got 7 point, all this other stuff over here. Again, the main thing is, though, is if we're going to solve for x, we're just going to take this number and divide it by 6. So before we write out all those decimal places, just go ahead and divide it by 6. So we know that x is going to be 1.23. If we go 3 decimal places, that'd be 1.232. Okay, so if they give you ln, you need to take e on both sides. And then one last scenario that we've got here. And we'll do 2, 3 examples, and then we'll wrap this thing up. So they give you ln. If you happen to have multiple ln's, you've got to condense it together to get it down. So you've got one ln expression, so then you can take e on both sides. And then the flip side of that one is that if they give you e, that if you have e in your equation, then you just take the ln on both sides. So if you have ln, you take e. If you have e, you take ln. Okay, now same rule still goes as it was before. If you're going to take the ln and the e have to touch each other. If you put the ln in there and it's not touching the e, it doesn't work. So you've got to work it around, rearrange it so that those two things are going to be there. Okay, so if you have one like this, we'll start off with the easy one here. If you've got e to the x equals 12, well, just do the ln on both sides. Okay, again, ln and e cancel. That's just x equals. Take your calculator, punch in ln of 12. And that comes out to be 2.4849. So that 9 will round up and make it 2.485. Okay, now, if life was always that easy with your expressions, we'd be okay. Now, here's where, again, you're going to have to, we're going to put some extra stuff in the equation to kind of throw things off a bit, just so you can see what to do. Let's say you've got e to the 3x plus 5 equals 12, where the 5 is not in the exponent, it's outside the exponent. Okay, so same thing. If you do the ln here, the ln will cancel, but this 5 is hanging out. So if you do ln on this side, yeah, the ln and e will cancel, but then you've got this extra 5 that's over here that's going to mess things up. So you have to get the e term by itself. So before you do anything at all, if the e term is not by itself, you've got to get that e term by itself first. So this extra plus 5 that's hanging around with that e to the 3x, you got to get rid of it. So it's e to the 3x plus 5. So the very first thing you would do is just subtract 5 from both sides. Okay, so now you've got e to the 3x equals 7. And once the e term is by itself, then you can go back in and then take the ln on both sides. Okay, again, ln and e are gone, so that's 3x equals ln 7. Go ahead and figure out what the ln of 7 is. So if we were solving this one, if it was x equals, it would just be that answer. But again, because it's 3 times x, after you get this answer, we've got to divide it by 3. So then just divide it by 3. So we've got, that's 0.649. Now, one thing I have seen, sometimes they may ask for an exact answer for x. So if they ask for an exact answer, it would be the ln of 7 divided by 3. So basically just tell me, whatever you were doing back here, just do that same thing. So if they ask for an exact answer, that would be the exact answer. And then if they say round it off to 2 or 3 decimal places or whatever they ask you, that's when you actually punch it in the calculator. So they may ask you to do that just to leave it in ln or log form or something like that. Same thing back up here. This answer could have just been, now this one would have been a lot easier. That answer would have just been x equals ln 12. There's not really anything with that one that would have been. That's one where we're gotten a little bit kind of complicated there. Yeah. All right, and then one more. Last one of the day. Okay, so let's go 3e to the 5x minus 2 equals 1972. Okay, All right, and same thing as the one before it. This e term that's here, we've got to get this e term by itself. So we've got to get rid of the 3, and you've got to get rid of the -2. So before we do anything at all, we're going to do just like we do in a normal equation. We're going to add 2 to both sides. We've got 3e to the 5x equals 1974, and then we're going to go back and divide both sides by 3. Because again, if we put ln here, it's not going to do us any good, because if you take the ln here, the L and the E aren't touching. That 3 is in the way, so we've got to get rid of that 3 and get it gone. Okay, so that should be e to the 5x equals, if we do 1974 divided by 3, that is 658. Okay, and again, now that the e is by itself, now we can take the ln on both sides. Now, technically those should be up here. Put those right beside it there. Okay, again, ln e cancel, that leaves us with 5x equals the ln of 658. If it asks for an exact answer, that's the ln of 658 divided by 5. If we need a decimal answer, that's where we'll just take that number and plug it in the calculator and see what we can get there. Let's do the ln of 658. And again, make sure when you do the ln of 658 that you close off that parentheses or hit equals and get that number and then divide it by 5 so that it doesn't try to tie in the things together. So then that's 1.298. Okay. Okay, so there's everything we're doing. That it's basically take something in log form, rewrite it in exponential. Take something in exponential, rewrite it in log form. Take something with ln, rewrite it with e. Take something with e, rewrite it with ln. So it's basically whatever they give to you. Just make sure you know that whatever they give to you, if you can't look at it and solve it, then you've got to rewrite it in a different direction and be able to go with it from there. And it's using your properties. It's doing a little bit. Have to do a little bit of condensing, like we were doing back here along the way. Shouldn't have to do a whole lot of condensing, but there'll be 2 or 3, 4 questions where you may have to condense it together and then take the E or the ln or whatever it is that you need to do from there. So, okay, that's it. That's all we got for today.